Hi, my name is Steve Murphy with Teledyne LeCroy. I'm here today in Rochester, New York with Saelig Company, where we're introducing some of the features of our high-definition oscilloscope, the HDO4000 series. We'd like to show you today some useful tools for documentation. You've got to always, when you find things and you circuits and issues, you want to be able to document it easily. So let me just quickly describe that, how you would do that. I used WaveScan here to identify all of the widths in this case, and we found, as we looked at the widths, things that that we were not happy with. We found a width that was very narrow, a glitch, and what we did is we used the scope to and WaveScan to identify that glitch. I want to document this. This is a problem. Let's do that. So we could document it here under Print Setup. And you could save it as a JPEG or a PNG file or a TIFF and bitmap. No problem. That would be the image that we see here with a white or black background, your choice. You could also, under File, you could save the waveforms and save all that are displayed. In this case, we have two waveforms. But you could also store it as, so binary, ASCII, Excel format, CSV, in MATLAB, MathCAD format. So these are all choices now that you're going to document the results by saving the waveform. I personally like another one called Lab Notebook that makes all of those, ties all of that together and creates a report with all of it in one report. So this is called Lab Notebook, and I'm going to create one right now. And I'm going to say, you know what, actually let me do this. I'm going to close this dialog down. I'm going to create a lab notebook. Here we go. And create a lab notebook. There we go. You name it something unique. I'm going to just keep it as the timestamp that definitely makes that report name unique. You could type in, hey, I found this. I was working with this device and it gave me this result. Or, oh, here was a glitch. You know, whatever. You can just add in this feature. The details to this report that we're generating, and we're going to hit save. And now with this save you can keep it as it is, but I want to annotate. I want to say that, hey, you know what, here is this glitch. And you know what, in the parameter table we also found that there was a glitch because the parameters showed the min and the max and showed a narrow width unexpectedly here. So if we do that, and then we say, hey, that's where it showed it right there, 165 nanoseconds. We can say, you know, yikes, not good. So I'm just showing you some type of any annotation you would like to, you know, add in here, you can. And you can erase this and put more formal and make it look prettier and all that. Also with a white background if you prefer. And I'm just going to go ahead and hit save right now. So what we've done is we've saved this image into this database, and you can see I've got 6 databases. I just say, and each database can have multiple reports in them. I just created a new report, which is the timestamp, and in this database it creates a sheet for you, and let's look at that. And it shows you the name of the report, the scope that you're using, time of day, and any comments that you just, you know, saved when we went and saved the notebook file. And on the top right, you put your company logo. I left it as Teledyne LeCroy. And there's the annotated image and all the scope settings that were done, that was saved at the time this report was created. And I can save all this details here into rich text or PDF or HTML or zip all of this in a WinZip file. So all that can be done. And what I'd like to do though is show you that there is the ability to flash back. If I take this off, so I have no signals going into channel 1, which is what I required, I can flash back now. And if the waveform data was saved in the database, the image was saved, and the panel setup So now I can go ahead, I could turn on cursors if I want, and put those cursors anywhere within the data. And you know, no problem with just starting to make some measurements, the width of that glitch, and maybe FFTs we want to do. So we have the actual waveform data with the panel setup and the images all stored as a report within as many databases we want. The databases reside on the hard drive in the scope, or it can be in a network drive if you have this connected to your network, or you could also save it on a memory stick so that you would have that for later use and put it on, bring it over to your PC. So real powerful tools for documentation. Thanks very much for your attention. Please call the Saelig company to get more details.